Welcome to the latest episode of the MFG Radio Network's Manufacturing Matters, where industry experts take deep dives into the latest technologies you need to consider to keep manufacturing moving.
Hello, and welcome to the latest roundtable discussion from GIE Media's Manufacturing Group as we discuss how to implement and benefit from additive manufacturing. I'm Jake Kaufman, a managing editor here at GIE, and panelists are standing by waiting to answer questions about the latest advancements in equipment and material for additive manufacturing. First, however, we'd like to thank today's sponsors, Iscar, Ascent Aerospace, and 3DO. Iscar is a full solution provider of metal cutting tool products and accessories for CNC machining. Launching hundreds of new products for machining each year, Iscar is where innovation never stops. Ascent Aerospace is a world-renowned single-source provider of production and automated assembly systems for the aerospace and defense industry. They produce a full suite of both mold and assembly tooling required for the aerospace manufacturing market, including the largest Invar mold ever made. They are the largest tooling group in the industry. They work with customers to develop their projects and see it through, from process engineering to build and installation, to ensure it is an efficient and cost-effective solution. And 3DO is an award-winning design, engineering, and manufacturing service specializing in small, complex metal 3D printed components. The end-to-end service interfaces with customers at any stage of the development lifecycle to ensure seamless transitions into production at scale without having to use multiple suppliers for the same part. Now that we can get to today's discussion, let's get to the panelists who will be joining us. As Patrick Klein is the National Product Manager for Hole Making at Iscar. Pat is a manufacturing industry veteran with more than 35 years of experience, 30 of which have been with Iscar. After he graduated from Tarleton State University in the Texas A&M system with a Bachelor's of Science in Manufacturing Technology, he pursued additional industry training and management, quality, and CAD/CAM systems. He's excelled throughout his career as a machinist, CNC programmer, manufacturing engineer, shop supervisor, engineering manager, tool designer, and cutting tool product manager, while being employed at General Dynamics, Boeing Aerospace, Superconducting, Super Collider, and now Iscar. We are also joined by Paul J. Walsh, who has 20 years in executive experience or executive leadership roles at Fortune 500 and smaller privately held companies, including deep operational experience in aerospace composites. His expertise lies in general management and acquisition integration, operations and program management, and market business development for high technology businesses focused on aerospace and defense. For the past 14 years, Paul has served as the division CEO and corporate COO at Ascent Aerospace. His responsibilities include growing the defense portfolio, turning around an unprofitable unit, program management training and development, leading large project capture strategy, integrating 3 former competitor companies, and management of talent and development. And Matt Petros, PhD, is the co-founder and CEO of 3DO, the award-winning design, engineering, and manufacturing firm specializing in complex metal components made with their proprietary metal 3D printing technology, intelligent layering. That's powered by 3DO's patented integrated technology stack and in-house expertise in design for additive manufacturing. Matt received his PhD in the field of advanced manufacturing technologies, including additive manufacturing from USC. So, gentlemen, thank you all for joining us today. And let's get right to the discussion as we start things off with Pat Klein over at Iscar. So the question for you, Pat, is there still resistance in the manufacturing industry when it comes to using 3D printed parts or using additive manufacturing as a whole?
Jake, yes, humans were creatures of habit, and we get used to doing things a certain way. A lot of times you'll hear in the manufacturing world, well, that's just the way we've always done it. It doesn't mean it's the way that it's always going to be. So what I am going to say that's encouraging, Jake, is we're seeing more and more companies starting to adapt technologies such as additive manufacturing, and they're going about it. It's not going crazy, but again, you have to remember a lot of times it takes a while for technologies to be accepted, implemented, phase out the old way, bring in the new. And you still have a lot of people out there with the old thoughts of I remember in 1996 at IMTS was the first time I seen a 3D printing, and it was with the looked like a sugar cube type of stuff, and it was really a show and tell piece, and it wasn't very strong, and so a lot of people have this thought process that the additive manufacturing is something less than what it actually is. And so we're slowly overcoming that mindset of, like, I'll just be honest, you hear a lot of people in the industry say, well, it's weak, it's not very strong, or it's kind of a cheaper version of what I'm going to call tear down manufacturing, which is when you start with the big block and whittle it down. But so there is still a little resistance, but I can tell you from traveling all across the United States and visiting different customers, you can see the trend that's shifting, and more people are adapting the technology and embracing it. So there's still some resistance, but there's less and less every day.
Awesome. Thank you, Pat. So we go to Paul then at Ascent Aerospace. Now, Paul, are you seeing some resistance when it comes to using additive manufacturing, or has it really been embraced?
I would echo what Pat said. There is natural resistance to any new technology because it poses a risk, right? So if you're an aerospace manufacturer or some other manufacturer, you've got customer obligations and liabilities. You want to make sure whatever your part you're buying is going to do the job and not have not be a liability. So in our business, making molds, tools, customers want, there's the added issue, I would say, they want a consistent set of things. If they have trim molds that are made out of aluminum, they don't want the fourth one to be plastic, right? They want a consistent set. So that's an additional hurdle that we face on top of the normal hurdles of this is different, this is new, how long does it last, and all the myriad questions. But it is gaining a foothold, and it's one of those things, as all new technologies, it takes time and exposure, and a bad incident like what Pat referenced will set things back also.
Awesome. Thank you, Paul. So Matt, we will wrap things up in this round of questions with you. Is there still resistance to seeing additive manufacturing being used in the industry, or is it something that you have seen pretty much embraced?
Yeah, I would agree with the other panelists. I think some of the things that Pat was saying is pretty interesting. Technology has come a long way in the last, almost 30 years at this point. Some things worthy of note are that, in the past, I would say decade or so, there's been great strides in developing standards, in making material comparisons. There are a lot of technologies where, with the advent of post-processing techniques, material properties, especially in metals, are rivaling those of raw materials, or getting very close to. And you're seeing a lot of these developing standards starting to go onto drawings when additive is being called for. One thing I'll point out that I think is very interesting is that additive is developing very fast compared to other traditionally manufactured technologies that had been developed, 50, 60, maybe longer years ago. And one thing I'll point out to the audience is that a lot of the time what we'll find is that there are experts within companies that have studied or have seen additive, and maybe their knowledge is dated to 3 to 5 years ago. And what I would encourage them to do is to challenge their internal teams to make sure that they're up to the very latest in knowledge of where the technology is at, because something you learned 3 to 5 years ago probably is not the truth anymore.
Awesome. Thank you, Matt. So we go to Paul then for our next round of questions. So are you seeing additive manufacturing being used in full-scale productions, or is it still just the main focus of printing parts and little products for custom jobs?
For us, it's again, we're building assembly lines and all the things for for an airplane manufacturer to be able to make airplanes. So the size and scale of the 3D printer that we have, it's 40-foot long and 10-foot wide. So we're making these big molds, things like that. It is getting used in some of the, like the eVTOL market, where they're making many smaller airplanes, things like that. It's starting to get a following. They're more, I would say they're a little more innovative. The bigger Boeings and Airbuses are a little slower to adopt something new just out of risk. We got to know that our production line is going to produce at X rate, and so they're going to be a little hesitant sometimes. So it's spotty. There are bright spots, and then there are other areas that it's probably a slower go.
Awesome. Thank you, Paul. So Matt, we will ask you the same question. Are you seeing 3D additive being used in full scale productions, or is it mostly for custom jobs for 3D printed parts and products?
I will speak to metal. I would say there are cases of full scale production for polymers, for metals, and for sure. In the metal world, some interesting examples, I would say in the dental space, probably hardly anybody knows about this example, but the largest supplier to dental labs of things like implants, metal copings, and such, these are all made on laser sintering machines at full scale. That is the largest supplier in the U.S. that is doing that. Tons of medical implants are being made this way. Medical devices are starting to head in this direction. Smaller quantities, speaking to kind of what Paul was speaking to here, but in the space industry, rockets are heavily invested in large-scale 3D printing. SpaceX and all the bigs you have heard of in the news are all thinking this way. And I think the commonality amongst all of them is that they are all having to do it out of necessity, having to take advantage for 3D printing in a way where it provides benefits that other traditional manufacturing technologies do not. And that's kind of a theme of how we think about things. Like in the medical space, high customization at volume. The dental space, the same. For rockets, really complex parts that are large, that are hard to reach in different types of places and features. And I think that's going to be the trend that continues to push additive slowly but surely into the mainstream, is realizing what it is and what it isn't, and just trying to take advantage of what it is.
Awesome. Thank you, Matt.
And I have a crown in my mouth that was 3D printed on my tooth. So I can attest to that laser sintering. Yeah.
See,
Awesome.
Now it's in action. Perfect. Always got to love a firsthand experience. So Matt, we will stick with you for this next round of questions. Can you use additive manufacturing to produce cutting tools, and what is the progress being made on that front?
I think I would probably be the least qualified in the bunch to answer that one. I can speak to customer engagements we've had and discussions I've had. I know all of the big cutting tool manufacturers that we've heard of, US and global, are exploring this very deeply. I think we are headed in this direction. I know of it happening at a much smaller scale. And I know the biggest interest in this is like, a lot of cutting tools are made in huge volume, and those processes are really well dialed in, and they're good at what they do. They manufacture really high quality products very economically. But for a lot of smaller tool orders, like custom tool orders, specialized tooling, that kind of thing, there's a lot of interest from all of the bigs in additively manufacturing those. At the core of it, it's a materials problem. Surprise. But I am seeing it being done at a smaller scale, and I know that there are products being shipped in this regard. It's just it's a heavy lift on the tech side, so we're working in that direction, as I know.
Okay, thank you, Matt. So, Pat, we will go to you at Iscar. How is AM additive manufacturing being used to produce cutting tools, and kind of what is the progress being made there?
Well, it's very interesting. Iscar, we like to say we're the company where innovation never stops. So as a company, we're embracing additive manufacturing, and we have for many, many years. To back up something that Matt had said, maybe 6 or 7 minutes ago when he said, if you know something from 5 or 6 years ago, you're pretty outdated in this industry because it's growing really fast. Well, 5 or 6 years ago, for us as a company and for many other cutting tool companies, it was pretty much just custom tooling. Get a proof of concept tool out there. You need to do a quick runoff at a manufacturer. The tools lacked the resiliency to be put into a 24/7 production environment. And exactly what Matt said, the main challenge to that was the materials that were available. If you want to drop back, say 6 7 years ago, at best you could print would be alloy steels, mild alloy steels. They didn't offer the strength and the resiliency or even the hardness of what you could make from raw material. Nowadays, with the advancements, and most of the advancements are not only within the machines themselves, but the material, you're able to print in a multitude of, you can do Inconels and titaniums and stainlesses. And for cutting tool companies, we can do tool steels. And so now we can have a tool steel printed body. And, obviously we have to come along and finish machine it because the finishing is not quite there yet. But you're able to get basically the same strength, the same resiliency, and therefore you can put it in a 24/7 lights out operation. I can't remember which of the panelists, I believe it was Paul, that actually said, you have a certain responsibility to your customer, a liability and things that they expect. Well, you're not going to get a big tier automotive company to put into something if it's not going to be repeatable, consistent, that they can count on to run 24/7 lights out. And now we're seeing, with the strength of material from the additive manufacturing, the different matrices of materials, it's right there. So, I mean, we're on the cusp of seeing, I think, widespread manufacturing. And one other point I would like to make, there's certain things within additive manufacturing that actually makes a better tool than say the traditional method. Specifically, let's take drilling, which I'm responsible for. You have to, if you have twisted coolant, if you actually look at the fluid dynamics of it, if you just take the traditional drill a hole, as it goes around these features within the coolant channels, you have restrictions, you have flow reductions, pressure increases. Well, now with technology, we can take and we can change all of that and 3D print it. If you have a 3 millimeter drill, your hole's 3 millimeter the whole way through. You don't have a way to alter that. Additive manufacturing offers that. Also, if we wanted to turn 90 degrees and blow the chips back up out of the hole we were drilling, you can do that with additive manufacturing. I don't know of a drill. I mean, Iscar doesn't produce a drill that you can use and turn a 90-degree corner and come back up and not be able to use it a second time anyway. So, the technology is really improving. It's really exciting. And I think there's going to be a lot more advances in the near future in cutting tools.
Awesome. Thank you, Patrick. So, Paul, we will go to you for our next round of questions. Now, when it comes to your actual company, are you using any 3D or additive manufacturing with jigs, fixtures, or other parts that are on your shop floor?
Yeah, so our product are jigs and fixtures that we're building on a large scale for all the aerospace companies. We do use it internally for instance, for holding fixtures. We have big machines, and we actually have a project now where we're using an additive printed holding fixture to support a workpiece that has to be machined and drilled and so on and so forth. So we use it internally. There it's really easy. We use it for some masters. So we have a composite shop making carbon fiber reinforced molds. Mm-hmm. And we'll use the 3D printed mold basically as a master that you would take a splash off of that. So those are two examples where we use it actually in the production of a mold or of an assembly tool or something like that. So, yes.
Thank you, Paul. So Patrick, we will go to you with the same question. Is additive manufacturing or a 3D printed part something that Iscar is currently using on the shop floor, whether it be, in jigs or other fixtures?
Yes, definitely. There's just certain things that you can make really quickly. Even the process of additive manufacturing would be quicker than taking a big block of material and whittling it all down to a very small, thin shape for that. So, it really lends itself well to those types of things. And I know from just going out into the field and seeing what a lot of our customers are doing, it seems that that's one area where they've really embraced it with if they need a big structure, some kind of welding fixture or jig to support something, they will 3D print it. Almost all manufacturing engineering offices I go in will have a couple of small 3D printers, and a lot of times they're printing either composite or a plastic material, and they're using it for innovative things. It's like if you have it, you'll find uses for it type of saying. They'll make nice little toolboxes that will hold a certain, if you will, toolkit to produce a certain part. And so they'll make these toolkits and holders and special things that hold parts a certain way so they can inspect them and look at them. And we utilize some of that at Iscar as well whenever we're producing products. So definitely seeing some fixturing and some work holding stuff being produced with additive manufacturing.
Awesome. Thank you, Patrick. So Matt, we'll wrap up with you on this line of questions. Over at 3DO, what sort of, or are you using 3D printed objects, products, on the shop floor? Is it something that's, in use at 3DO?
Absolutely. We use additive, believe it or not, to make parts for additive machines, which is pretty interesting. We also, in our production machines, we also obviously prototype and ideate with 3D printers. 3DO, as you said, is really heavy in design for additive manufacturing consulting. We collaborate with our customers in this, and so a lot of the times we will print either in metal on our technology or in plastic if that's easier and faster, in order to have something to speak to and collaborate on with our customers. But we are 3D printing through and through for sure.
Awesome. So I will stick with you on this next round of questions as well, Matt. So what kind of post-processing needs to be done when something is additively manufactured with metal? What are, sort of the things that need to be done before it is ready to be shipped out the door?
Yeah, I can speak to generalities here. At the end of the day, surprise, surprise, it depends mostly on what the customer requirements are, right? At 3DO, I would say most of the things that we ship, if we do anything to them, it is most likely a heat treat. That is very, very common, not just for 3DO technology, but a heat treat or a annealing process is very common for a lot of metal additive technologies. Machining for sure, all the time. Most common for us would be a customer has a call out for a hole tolerance that's in the tenths range. We are never going to hold that in additive, period. Nobody is. And the proper way to do that is just to undersize the hole, drill it, ream it, find threads. These kinds of things are kind of the most common. Anything that you would potentially do to a metal part in general, traditionally manufactured or additive manufactured, I would say is fair game. Polishing processes, grinding processes, post-machining processes. I mean, really the whole gamut, plating, all of these things play, and we have tried or done in production at one point or another.
Awesome. Thank you, Matt. So Patrick, we'll wrap up this round with you as well. What kind of post-processing needs to be done to an additive part that has been made through metal, before it does get out the door, before it heads to the customers?
Well, I want to commend Matt there, the fellow panelist. He did a good job on hitting a lot of the topics that's going to be there. You've got to still do the basic things. If it's got to be heat treated, which everything basically that we're going to produce is going to be heat treated, you have to do the heat treatment process. Depending upon the complexity of what's taking place, you may have to stress relieve it first before you heat treat it. Anything with it, just because it's 3D printed doesn't give it any corrosion resistance. So any type of final finishing, Matt had mentioned polishing. We polish a lot of our tools, but also we have surface treatments that go on them to give them corrosion resistance. That still has to be done. I wish that the finish would be a little bit better and we could eliminate some of the secondary machining operations that has to take place. But right now the technology is such that the finish you're going to get is going to be very, very rough. And so you have to do finish machining, which brings up a very unique situation. As more and more companies go to this, you're going to see companies like Iscar. We have a complete line of tooling, whether it's turning tools, milling tools, drilling tools, and we call the family Neo. And the reason why it's Neo is it's very, very small. And the tungsten carbide, you pay pretty much per cubic millimeter for the stuff. And so if we can produce smaller inserts, then we can give a cost advantage to help customers lower their cost per part. And so whenever you 3D print something, you leave very little material. As the technology's improved, you can get closer and closer to net size. So you're starting to see cutting tool companies like Iscar producing very small cutting tools because they're not going to take off much material. And so there's not a need for a big piece of carbide or even a big tool. And so that's changing the cutting tool industry itself as we go to these Neologic small tools. And, it's only going to continue to improve, going back to what Matt said about 5 or 6 year old technology, we're able to do so much better with additive manufacturing now, getting so much closer to near net size. And if you think about the cost savings long term for aerospace or any of these other companies, that's into these really high dollar materials, 718 Inconel, titaniums, if you can get something where you're not turning a lot of it into chips, it's actually, you're just making a small amount of chips and it's a huge cost savings and time savings, and they're able to utilize that. So, like I said, the technology is growing by leaps and bounds. And, I don't see any time in the near future you're not going to have to be able to do some post treatments after the additive manufacturing process. But there's obviously no additional treatments required compared to, say, the conventional method.
Awesome. Thank you, Patrick. Now, Paul, we bring you in for the next line of questions, and I have an idea of where you're going to focus on this one, but here at GIE Media, the 4 industries that we mainly focus on are medical, aerospace, defense, and electric vehicles. How have you seen additive manufacturing used in those industries? Is there a specific one that you've seen really embrace and run with additive manufacturing?
So I for the most of my career, I focused in aerospace and defense. Mm-hmm. So I think I can talk to that. Certainly, Matt had mentioned rockets and things like that. So I used to spend, in a prior life, I ran a business where we made components for turbine engines for the hot section. Those are things that have tons of tiny holes. You're basically operating refractory metals above their melting point because you cool them. 3D printing allows them to print what they can't even put holes in anymore. I mean, the old way is you would have a casting, and you'd cast the metal in a ceramic mold. You can't even get the size of the holes that they want. So 3D printing is really changing how to make turbine engine components. For, let's say, flying parts, I'm not aware of a lot of, other than metal. There's metal flight hardware in rockets, in airplanes, that's becoming much more widespread. It's a lot less cost to print something than to whittle a block of metal down into a part. For one of the things that, as Pat was talking about cutting tools, I started thinking we use a ton of bushings carbide bushings in drill jigs and jigs and fixtures. They have pinups. Those things are long lead items that take a long time to get. So I plan to give him a call afterwards and ask, do they make bushings? Because that's a very real, we have a very real need for stuff like that. So in the building of equipment for jigs, fixtures, and we're talking big assembly jigs for assembling a wing, putting ribs and stringers onto a wing skin or a fuselage. That's the scale that we're doing those kind of things. I would say it's starting, but I don't see tons of parts being 3D printed yet.
Thank you, Paul. So Patrick, we'll go to you with the same question. The four industries now that we focus on: medical, aerospace, defense, and electric vehicles. Have you seen any of those four industries really embrace additive manufacturing and kind of run with it?
Aerospace, I see more than any. And again, rockets, I also lob into that aerospace industry. And what I'm seeing is for a couple of different reasons. One, we had COVID and all the supply chain issues. And I hear from a lot of manufacturers that they are really suffering from getting their forgings. And sometimes as much as 96 weeks out on forgings. And so this is a huge delay to their process. And they really hate to go to getting a block of material and whittling it all down, because so many aerospace parts is always about weight reduction. They're very thin walled. They have a lot of structures and support elements to them to give them the strength, but they're very thin. A common process in aerospace would be to chemical mill, say aluminum or something, so that you do a weight reduction. And now you can 3D print it from the get-go. So that's very good for them. It helps with the reduction of waiting on forgings and things that they're having to wait for. And then the fact that the material is expensive and they don't have to turn a lot of it into chips makes those ideal places for it to go. And there's also manufacturing challenges. I know, for instance, if you look at some rocket parts, like for instance, the nozzles where you see all the smoke and thrust coming out of, those are very hard components to produce. They're very big in diameters. They're very thin wall. Any cutting tool that you put to them causes stresses to be developed within the part. It's a long process. So these are areas where additive manufacturing can help. Mainstream automotive, I haven't seen a lot of additive manufacturing as per se. The electric industry, yes, there's a lot of aluminum pieces and things that they produce. Right now, I guess the main traditional method would be cast aluminum for a lot of them, but you're starting to see more and more of them go to 3D printing the aluminum pieces for these electric vehicles. So I would say more in those industries. Aerospace and the EV market, in my experience, what I've witnessed myself, seem to have embraced it more than the other industries. I haven't seen a lot of it. And you're talking about medical. I haven't seen a lot of it. And to be honest, I never thought until Matt mentioned the dental implants. I'd never really even thought about that. But I've not seen a lot of it in the dental that we're in. But again, the dental shops we're in are mainly Swiss machines, and Swiss machines are, knocking out hundreds and hundreds of bone screws and things like that. So I'm sure it's getting there. I just haven't seen as much of it as I have in aerospace and obviously the EV vehicles.
Awesome. Thank you, Patrick. So Matt, we'll wrap up this round with you. Out of the aerospace, medical, defense, and also electric vehicle markets, which one of those have you really seen embrace additive manufacturing and kind of run with it?
None of the above? No. I think I would say embrace and run would just be too strong for any of the industries. Okay. I think I'm generally in agreement with Pat in that I think the broadest applications and use cases that I've seen have been in the aerospace industry. I would say that it's probably no exaggeration to say that aerospace combined has probably spent the most, on the order of high hundreds of millions to maybe low billion scale in research and development of additive manufacturing processes and applications. But on the whole, I would say they are also kind of crippled by what I would call just general bureaucratic inertia, individually at the OEM level, but also at the sub-tier supplier level. And there are all sorts of complicated interaction effects between the organizations. Like maybe the OEM might pass something, but that information isn't transparent and directly communicated to the sub-tier supplier that is making those parts, right? So a lot of the uphill battle with additive, really with any new technology, not just additive, is figuring out how to bring all these parties together to come to some sort of transparent agreement on very specific applications, and then move them forward in that way. And that's a lot of the work that we try to do here at 3D as well.
Awesome. Thank you, Matt. So we'll stay with you for the next round. Where are you seeing the greatest impact when it does come to using metal additive manufacturing? And what are the material options when it comes to printing now? What are sort of the best ones out there that you've seen?
Gosh, I think as far as biggest impact, we've kind of hit some of that. What I will say is that it feels like we're turning a corner in general in additive and metal additive specifically, where a lot of organizations have at least a cursory understanding of, like, you know, that all the hype isn't quite real, and we have to really understand what's happening here. And I think that in general is really, really good and is broad sweeping across a lot of the industries that you had just mentioned. And a lot of the what I would describe as the biggest groundswell impact has been in this sort of change in thinking, of attitude towards, well, you know, clearly it's not going to replace everything. Clearly, maybe we shouldn't even be thinking about it replacing, but we should be thinking about it on its own for what it might help me do as a company. It might help me differentiate my products. It might help me improve performance. If I think about it holistically, it might help me with upstream and downstream costs in manufacturing and assembly. You know, people are generally thinking about it the right way. And I would say, I hope that's not a cop-out answer, but my general feeling is that the mindsets of people are really starting to change in a really positive way across all industries.
Awesome. Thank you, Matt. So Patrick, we'll go to you on this next question. What are the options and advantages of additive manufactured parts for large molds and fixtures?
Well, you know, I kind of touched on some of it before with supply chain issues and things. And, you know, it's really hard to wait a long time to get forgings and castings and things in. And molds typically have a lot of material removed. I mean, it's just the nature of a mold. And so that's a long process to remove that material. You've waited a long time to get it, and you're turning a lot of it into chips. So, and there's a lot of certain features in it, say in molds, injection molds, they have to have, they don't have to have high tolerance holes going through them. They just need cooling holes. Well, when you 3D print one of these, you can take those multiple operations. You know, Matt was talking about how can I decrease cost, you know, looking at it holistically and doing this. Well, if they take in and they're not having to wait, they're in the driver's seat. They don't have to wait for their supplier, however long it may be, to get their forging or their material, and they're able to take and produce it in-house. That gives them some of control of their process, helps reduce cost. They can combine certain operations all into one, so that they don't have to spend the extra effort in manufacturing, so they can reduce their costs there. And, you know, the world we live in is very fast paced, and there's a lot of changes that just have to happen quickly. And additive manufacturing is, you know, pardon the pun, but it's on the cutting edge of this technology to allow rapid changes in real time. And so they're able to make these changes. And dies themselves, you know, a lot of times, you know, some die manufacturers will get a change to their order midstream. And if they've already ordered these forgings and they're already made and they're en route, they're stuck with either having to remove more material than they initially wanted to, or even having to add material to it and then end up reworking it from the very get-go. So this having more control works towards it. And like I said, the fact that most dies are typically very large with a large amount of material removed, it kind of, I'm gonna steal from Matt where he said we don't really need to think of it as replacing, but adding to. That's a good analogy, and so you have tear down manufacturing and build up. And when you look at it, and I don't know the exact break point to where one's better than the other, but if you've got a mold and you're removing 80% of the material, would it not be better just to build up and only build up that 20% instead of having to tear down 80%? It kind of makes sense. But it depends on the type of molds, because if they're stamping molds and they're having to see a lot of high force, the materials are still a struggle. And, because whenever you start, and I'm not trying to be an expert on stamping dies, but whenever you start putting 20 and 30 and 40 tons or more of pressure on additive manufacturing steel, it's hard. And not that it can't be done, it can be done. They just don't seem to have enough resiliency to be what I'm going to say put in 24/7 production. So it depends on when you're talking about dies, that's a big question. And I'm not trying to cop out and be a politician and walk on both sides of the line, but as long as it's not a heavy stamping die, if it's an injection molded die, definitely additive manufacturing is great. If it's some type of die that's used in composite layups and things, definitely a good source. And so that's a good industry for it, simply because of the amount of metal removal that takes place.
Awesome. Thank you, Patrick.
Yeah, Pat,
Oh,
sorry, may I make one comment? Pat, I don't think you're walking both sides of the line. I think you're hitting it right on the head. And I think you did a really wonderful job of saying, like, look, there are places where additive can be put in production 24/7, and there are places where honestly it shouldn't. And I think that the more people realize this and realize that it's like a gray area, the better the development of the industry will be. So I appreciate you saying that.
thank you, Matt. So, Paul, we will wrap up this line of questions with you as I ask, what are the options and advantages of using AM parts for large molds and fixtures?
Speed and secondarily cost. So speed. We built a roughly a 35-foot long by 10-foot wide trim tool. We printed it, I think it was 4 or 5 days. If we were to build that in metal, the fabrication part, making an aluminum one, would have taken 4 weeks. By the time you welded it all up, you heat treated it, did all of that. So you still have to go through the follow-on steps of machining, which is the same whether it's plastic or aluminum, and all the assembly operations. But just the fabrication of that surface, 4 weeks versus 4 days. That was the advantage. And that's for the customer, and it was a rocket customer, it was a huge advantage. A lot of them are under the gun with, they have late engineering, they've got changes they want to roll through. So the speed is really the key for many of these things. Cost, sometimes it can be a wash, sometimes it can be cheaper, one way or the other. I also want to tack on to the comments that both Pat and Matt made. The usefulness of a 3D printed part, whether it's a big mold or anything, you got to remember, you have a couple thousand years of metalworking experience, and you have a couple, maybe 100 years of plastic and composite experience. And now you've got this new manufacturing method, 3D printing, that's not whittling material away. You're building it up from the get-go, like a seashell would be made. That's how a animal makes a shell. It's so different that people do struggle with it, and it does have risks and liability, especially for flight hardware. So as a materials engineer, back in my day, you've got to be really confident that that material is going to hold up, that you're offering it for sale, and you know, today, in today's litigious society, you got to make sure that you have a good product that's going to stand up to the rigors of however it's getting used. So I think that's the challenge, and we should. I agree also, it's going way faster in some cases than I would have ever expected. In fact, I told my kid, get into, be a mechanical engineer, don't be a materials engineer, because it's generational to get people to change materials. Changing manufacturing methods is a similar thing, right? It's just a challenge. So I'm impressed with the speed, and the key, I think, is the standards. Somebody said earlier, standards. Having standards that people can specify is a big part of making this successful.
Awesome. Thank you, Paul. So Matt, we'll go to you with our next round of questions. Now, when it comes to an individual worker, how is 3D printing, additive manufacturing kind of changing what their role, what their responsibility is in the factory?
Gosh, that's a tough one. I would say, as far as individual workers go, putting my operational hat on for a second, the most direct way they are affected is with all sorts of, like in our factory floor, we have all sorts of very interesting custom plastic and metal tools and I guess handworking equipment that make their jobs easier and faster. I think we also have been empowering some of our technical staff with the, we obviously like everybody's input in a continuous improvement type of culture. And I think giving them access to these really low cost plastic FDM machines, for example, allows them to put some of their ideas into practice with very little cost or effort. And so it's really an empowering thing on both a continuous improvement track and just from a cultural, like, good feeling perspective. So I've been very pleased on our side.
Awesome. Thank you, Matt. So Paul, will ask you the same question. When it comes to an individual worker, when using additive manufacturing, 3D printing, what is their role and their responsibility in the factory?
Our guys in our factories work with a variety of different materials, from composites to metal, so they're used to that. I would say the places where we see the biggest difference is design. Mm-hmm. So if I'm going to design a mold out of metal, there's, I've got to put forklift tubes in it or lifting things. For a plastic part, I can print the forklift tubes in it. It's a very different design. And so getting people, I would say, get them to think, not think like this is how I build it out of metal and now I'm going to make that same thing in plastic. I'm going to take advantage because I don't have to do certain things. I can by redesigning it to take advantage of the uniqueness of the manufacturing method, I can save a lot of time and save a lot of money. People who try to reproduce a metal in plastic that's going to be 3D printed, that's a fail. You really have to look at it a different way. I would say that's probably the biggest place where we see a big difference.
Awesome. Thank you, Paul. So Pat, we will wrap up this line with you. So what is the individual worker's role and their responsibility when using additive manufacturing or 3D printing?
Well, Matt and Paul pretty much touched on a lot of the things, so I don't want to be redundant. But I will say, to tag on to what Matt's saying, it is an empowering thing. And so, the technology is fairly simple to use. The user interfaces that I've seen are easy, very intuitive. And so it allows the people on the shop floor to be more involved. maybe in the past they only produced one small part of the widget, and you don't get to see, you don't get the job satisfaction, if you will, of seeing the whole piece. Now they're involved in a bigger part of the pie, if you will. They get to see more of it. That gets more buy-in from them because they're just not drilling a hole in a widget. They're actually making a total part. And also these machines, a lot of times you'll see that now people who, and again, if you take machining, there's certain rules that apply if you're machining aluminum, or if you're machining titanium, or you're machining Inconel or some high nickel based material. For example, in nickel, you can't have a high RPM and a very slow feed rate in any material with nickel, because nickel work hardens and it will make the part extremely hard. So therefore, a lot of workers in the shop floor were just button pushers. Somebody else did the brain power, figured out the speeds and feeds. And so the workers just kind of like a robot, if you will. They don't really get any input to the process. Well, with additive manufacturing, there's enough technology that's there already within the machine. I hate to use the word artificial intelligence because, you know, the world's freaking out on it right now, but there's enough artificial intelligence in the machine that it's going to produce that part at the correct parameters, where maybe if they were in a conventional manufacturing shop, they wouldn't be afforded the leeway to actually get to do anything but just push the green button. And so that makes it a lot more interesting for the workers, and it gives them more opportunities. And, you know, and here's the other thing. If there's a young person trying to come up in the industry, you know, and he's competing against people that's got 30 years machining experience and all that knowledge, well, if he's into the additive manufacturing, that's a fairly new thing. He's competing. It's a lot easier for him to take a quick jump up in his status within that company, because he's almost as knowledgeable as the next person that's in the facility. And so that gives job satisfaction. It gives him a bigger role in the process. And I think that's one of the things that's helping this drive this, especially with the, you know, with the younger kids and things that's getting into the industry. You know, it's kind of funny. You look at all the old movies like Star Trek, and they had the replicator where it made stuff. Well, look where we're at now. We're making stuff from nothing. You know, I mean, it's amazing. So I think it does empower the workers.
Awesome. Now, Patrick, while I have you here, it looks like Michael in the audience would like to know, do you find that additive manufactured parts have difficult chip removal and smearing issues?
Well, that's a pretty big, you know, brush you're painting with. Traditionally, not. But again, it depends on what processing was done after it. So if you have a material, you know, and let's just take Inconel. And Inconel, when it's in its soft state, it's really gummy and it's hard to machine. If you work harden it, then you can make nice chips and you don't get smearing. So it depends on the 3D additive. If it's straight off of this 3D printed and you try to machine it, a lot of times the materials are soft and it causes problems. And again, and I'm not talking back 5 or 6 years ago, whenever there would be some porosity and issues where you may have some inclusions in it and it would be weaker material, and it would cause your cutting edge to chip because of the interruptions and the inclusions. But typically with today's processes, especially if it's post-treated, then I don't see on a widespread basis, I don't see a problem with smearing or a problem with the cutting tools.
Awesome. Thank you so much. Also, it looks like we have another one. Patrick, is your company able to make carbide drill bushings, and are companies making such?
Iscar itself does not make drill bushings, but within the IMC group, we have a wear parts division that makes things like pins and bushings and gripper jaws and things out of carbide. So within the IMC group, yes, there is the capability to produce carbide bushings.
Okay. Does that answer your question, Paul?
Yes, sir.
Awesome. So we will go to you for our final round of questions. So at Ascent Aerospace, what do you think the future of additive manufacturing looks like? You know, we have talked about how, you know, if you're using technology that's 5 or 6 years old, you know, you're behind the time. So if we do this again in 2 to 3 years, you know, what are you thinking that we'll be talking about in the 3D printing additive manufacturing world?
For our business molds, everybody wants to be able to make a 3D printed mold and not make an Invar mold, which is expensive and takes a long time to make. CTE mismatch, coefficient of expansion difference for big things. If you're making an airplane skin, a wing skin, a little, changes in expansion coefficient manifest themselves in changes to how the composite would cure let's say the dimensional precision. So as the technology matures, I would expect to see more of that. I think we're still a ways away from that, but that's coming. And then I think we still make lots of stuff that we do as one-off. We might make locating features and fixtures and things like that today are whittled out of a metal block or made from an aluminum or steel fabrication. We've started to look at sourcing those kind of things. At some point, we probably, and some of our competitors have, I know of one that has a few machines for making small details and things. So I'd expect to see that grow as all of the companies, it doesn't matter what industry you're in, you've got a lot of capital on your factory floor for machines and other things. And as you start to hire those machines, you're going to buy additive machines.
Mm-hmm. Awesome. Thank you, Paul. So Pat, we will go to you at Iscar. In 2 to 3 years, we had the same conversation. What kind of additive manufacturing, 3D printing do you think we will be talking about? Kind of what is the future of the industry in your eyes?
I think we're going to continue to see it, get closer and closer to a finished part, meaning that the tolerances will be closer, leaving less material to be machined. I think the surface finish that we're going to get will be better. It's still, I think in 2 to 3 years, for sure, we're still going to have to finish machine. The technology, unless I'm totally wrong, is not going to advance fast enough, and it may never advance to get to where you don't have to do some finished processing as far as smoothness. Now, again, it depends on the part. If you can accept a really rough part, then okay. But I think in 2 to 3 years, what we're going to be talking about is going to be how little we have to do on the backside to finish the part. And I think we're also going to be talking about the fact of the strength of the material as far as, the improvement that's going to be made on the material side. I think will probably be the biggest improvement, in my opinion, that we're going to see. And then the other thing is these are adapted and more people figure out ways to bring this in-house and utilize it. You're going to start to see a lot of things where, you'll have honeycomb structures, even in cutting tool. Well, not so much honeycomb, but you'll have these lattice structures where, people will be making big diameter cutters, but reducing the weight of them by this process. And on the outside, there'll be a thin skin that's over this lattice network that's actually inside making up the body of the tool itself. So I think we're going to be talking about those types of things 2 to 3 years from now.
Awesome. Thank you, Pat. And Matt, we'll wrap things up with you. We had this conversation in 2 to 3 years. What sort of things at 3DO would you guys be talking about? What kind of do you see as the near future of the additive manufacturing industry?
Yeah, so I would totally agree that we would be seeing things like tighter tolerances, better surface finishes, hitting engineering specifications. I want to play off something that I believe Pat said earlier, which I thought was really spot on. Every high school that I can think of in the Los Angeles County region probably has a plastic 3D printer, at least one, in the classroom setting. Every engineering university has multiple. Graduates that are coming out are coming out with a knowledge that is on par and sometimes better than what organizations already have in terms of additive engineering, I would say knowledge in general, but with one important distinction, which is they don't have any of the inertia, any of the, hey, you can't do this because of these 20 years of experience that kind of fill my cup and don't allow me to think that way, right? And I think all that to say, 3DO is heavily focused on breaking down those barriers with design for additive manufacturing thinking. And I would hope and I believe that in the next few years, 3 years, 5 years, what we're going to get, because we have so much interest in mechanical engineering and manufacturing in this country again, I think what we're going to see is a heavy emphasis on design for additive thinking and people thinking additive first rather than thinking of a traditionally manufactured part and trying to figure out how to put that square peg in the round hole. I hope what we're talking about is things like, lattice structures with thin skins around them. I hope what we're talking about is what kind of special things can we do that we couldn't do before. And I guess I'm an optimist and a patriot in a lot of ways. I hope that all of this breathes a brand new life into American manufacturing, and I believe it will.
Awesome. Thank you, Matt. So I would not be able to wrap up today's discussion without thanking our sponsors once again, as we were joined by Iscar, Ascent Aerospace, and 3DO, as they were all able to be part of the roundtable, and specifically a massive thank you to Pat, Paul, and Matt. So gentlemen, I hope you guys all have a great day.
My pleasure. Thank you for having us. Great meeting you guys.
Thank you.
Thanks, Jake.
I learned a lot from the panelists, and thanks for having us.
No problem, guys. Have a good one.
You can find more Manufacturing Matters plus the MFG Radio Network's other podcasts on Apple Music, Spotify, Google Podcast, or on our websites at todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, and evdesignandmanufacturing.com.